Greetings folks and welcome to the Electromaker Show. This is your midweek roundup of all things maker and embedded and lovely. And on this week's show we're going to be looking at a real variety of interesting stuff. I just reviewed the new Blues wireless starter kit, or they're called Blues now, sorry, just Blues starter kit, and had a really good time doing so. And Robin, our in-house gadget guru, has just got deep into the Embeetle IDE, which is an IDE specifically for working with microcontrollers. We'll be talking about both in this week's show, along with announcing the winner of the Zimablade contest we started last week, looking at some insanely huge marble contraptions, and BeagleBoard's very fascinating new RISC V plus FPGA system on chip / SBC. And with all that to get through, let's get on with the show. We're going to begin this week's show by talking about the Embeetle IDE. Now, this is an MCU-specific IDE. It's an independent and integrated development environment specifically for working with microcontrollers, which in and of itself isn't necessarily that exciting because we have the Arduino IDE for working with Arduino, don't we? Or we have the Thonny IDE if you want to work with MicroPython. They're both very simple. You can use Visual Studio with Platform I/O. You can use the STM32Cube IDE. But what makes Embeetle so interesting is that this is a self-contained IDE for working with a wide variety of microcontrollers with a bunch of features that I've never seen on any other. Now, our in-house gadget guru Robin covers this on the Electromaker Educator video and blog post on the Embeetle IDE, and I suggest that you go and at very least read the blog post. His 18-minute video packs an incredible amount of information into it. I am going to just skip ahead to here. I'm going to keep the sound off. I want you to go and watch Robin's video and hear him narrate it, but I just want to say quickly what's happening here. This is opening the Embeetle IDE. Okay, here we are. We've opened the Embeetle IDE. We're going to create a new project, and the project he is creating is one for this. This is the WCH32003. I may have got the name kind of slightly wrong, but this is the 10-cent microcontroller that everyone was losing their minds about a little while ago, which is an incredibly powerful little part, but incredibly cheap. I talked about CN Low's amazing Dixie Tube power supply that he made with this, and Bitlooney made a cluster of them. There's a bunch of videos out there. But what you're watching here is a wizard that's taking you through setting up a project for one of these. It installs everything, the entire toolchain on your computer without you having to do any of the legwork. And as you're about to see, it spits you out into this, a full IDE. I'm going to make this big for a second. And so you have your code here, you have all of your build and your flash and debug stuff, and you can do, as you can see later on in the video, you can do breakpoint debugging as well. But this is the part that makes Embeetle so incredible. If you select the board, you can say click here for more information on their website, and their website is full of information, including the technical documents around it, things you need to know about it, little things that you wouldn't necessarily think about. For example, their STM32 documentation documents a well-known but not necessarily something you'd think to cover bug where if you don't wire up something to the 3.3 volts pin on a blue pill, the ST-Link won't talk to it. That's just one thing that can happen. The Embeetle documentation says, okay, yeah, here's the perfect example. The flash failed. It said, did you install the right board for your debug probe? So this is the debugger that comes with this RISC V chip, and sadly I received these just before I started recording today, so I couldn't do this myself. I wanted to have Embeetle open and start messing around with it and do exactly the same thing Robin did, but on the show, didn't manage to do that. But here's what it's saying. The flash failed, so do you need instructions as to how to install the software required for the flasher? And that's what it's showing you here. Now, as always, Robin will explain this far better than I am doing so, and I suggest you go and look at this. But other nice features about Embeetle, just before we move on, it's all entirely self-contained. Every single Embeetle folder contains everything that project needs. You can zip that folder and send it to someone else, and they will open it in Embeetle, and they will not need to install a thing. If you set up your project, you can run that project on any IDE. You can get someone with the same hardware as you and upload code to it. And again, that was my plan. I was hoping to get Robin's project file from this and do it for this. I ran out of time, sadly. Embeetle is it's a really nice idea. I can't think of anything else that really does this. I know there's probably people in the comment section who will say Platform IO does exactly this, but it doesn't do it quite the same way. The level of documentation here is incredible. And in fact, if you go to their website and you head to the forum, almost every issue is answered by the team. And it's not just 2 or 3 word answers. They're going through they're going through step by step with people. What's the issue you're having? Okay, check this. Check you're using exactly the right setup for all this kind of stuff. And are really trying to get the best experience for their customers. So yes, if you'd like a full rundown about this, head to Robin's article, watch Robin's video. It really is a thorough video, not only about Embeetle, but about RISC V in general as well. But the fact that the Embeetle IDE already supports this RISC V chip is something that I find really interesting. They've really made the effort to support this based on the buzz around it, and there's a bunch of other chips that they support as well. And as I said, there's just a few little things that make it a little bit different to how I feel many other IDEs work. I've worked in projects before where everything is completely self-contained. You can just pass the project and you don't have to worry about linking or anything like that. I've worked with IDEs where everything is easily labeled and it all links out to different instructions, but most of those things will link to the instructions from the vendor themselves. They've taken the time to make their own documentation about other vendors' hardware, including some of the bits, some of the kind of gotchas, like I said before, like the STM32 power pin thing, that you wouldn't necessarily get from the official vendors. You'd have to dive into forums or into Reddit or whatever. It's a really interesting concept, and one of the things that I maybe should have mentioned at the very start of this section is that Embeetle is absolutely free. It's free to install. I don't even know how they monetize this at this stage. So it is quite interesting, and if you are interested in an IDE that is specifically for microcontrollers, that is consistently under development and they're adding new things all the time, and has a team that will absolutely help you if you reach out to them in their forums, I absolutely recommend Embeetle. I'm definitely going to spend a lot more time playing with it, especially now that I have one of these wonderful little RISC V chips. By the way, maybe one of the benefits of getting a 10-cent chip on a development board is they just chucked a ribbon of 5 more of them in the box. So I have 5 more of these. So maybe I'll try and spin up my own development board at some point. Actually, that's terrifying. Now, on the last show, we started a competition to give away one of these, the Zimablade, and since then I've had the chance to actually fiddle around with it just a little bit, and I'm having a lot of fun. I'm working on a secret project that will remain secret for now. However, I also have a Zimablade to give away, including the entire Pro kit. So that's a Zimablade, that's RAM, that's a SATA Y kit, and everything else that comes in the Pro kit. And it is time for us to choose the winner of that. And our winner is Brandon Skodinsky 5764, who says, I would replace my RPi 4, my Raspberry Pi 4 that runs a MQTT broker for my ESP32 sensors around the house. Congratulations, Brandon. You are the winner of a Zimablade. And yes, when you do set that up as an MQTT broker, please do document your findings on how it goes on the Electromaker website. I'd be really interested to see what approach you take. And as to everyone else that entered the competition, thank you so much. This isn't the last time we're going to be giving away something like this. Of course, we give away quite a lot of stuff here at Electromaker. Thank you all so much for being involved. It's my pleasure that we have so many wonderful bits of hardware that move through our hands, and it's my great pain that I have to give away almost everything that touches my hands that is part of this show, but that's all part of the game, and I'm very glad that we get to do that. Anyway, let's get on with the rest of the show. Just a quick reminder that everything that we do at Electromaker is self-supported, in that we don't run any adverts on YouTube, we just have a shop. So if you head to electromaker.io/shop, you will find a vast variety of things, including some of the things that we talk about in this show. For example, we'll be talking about BeagleBoard later. We stock a bunch of BeagleBoard stuff. We were just talking about various different microcontrollers you can use the Embeetle IDE, whether you want to work with an Arduino Uno type of board or any of the Arduino line or any of the Adafruit line, including all of the feather boards. We stock all of them on electromaker.io/shop. And that is the way that this YouTube show is funded. Now, if you don't have the money to spend right now, although Christmas is coming up, so it's the perfect time to get gifts, but if you don't want to go and actually buy stuff in a shop right now, another way that you can help us is by clicking like on this video and making sure that you are subscribed to this channel. If you then click the subscription button, that becomes a drop-down box once you have subscribed, and click all notifications, you'll be notified just when we put new videos up on the Electromaker channel, and you'll only get those notifications in YouTube. But all 3 of those free things only take a moment to do, and it will give YouTube the very strong message that you do like what you're watching, and it will recommend it to other people. Thanks. Now we're going to move on to the Noisette Optical Theremin. Now you're probably familiar with the concept of a theremin. It's an instrument that you play by waving your hands around. One hand is the volume of the note and the other hand is the tone of the note, and we're all very used to the kind of like woo kind of sound there. Now this is an optical version of that uses ICs to create the tone and light sensors in order to sense what your hands are doing. And this is just a product. This was an email I received, and we're not affiliated with them. I just thought it was such an awesome idea that I wanted to feature in the show. So the Noisette Optical Theremin is from Zeppelin Design Labs. They make various other things, but this is specifically designed to be easy to do because this is a kit. In the past, I've talked about soldering kits that you buy just for soldering practice. This is a soldering kit that you can buy that will give you a handheld optical theremin that can work via a 9-volt battery or a 9-volt DC jack, and has an audio output so you can connect it to your pedal and all this kind of stuff, or you can use the inbuilt speaker. And in fact, before we go any further, let's listen to what it sounds like. The rest of the introduction video is absolutely worth watching, by the way. It's only 1.5 minutes long. It gives you a nice idea about what the product is for and how you can use it. And it shows you the important things, like, for example, it's perfect to do with kids. It's all through hole. That's what makes it so easy to use. And in fact, if I show you the images of the kit here, it comes with a PCB, and the PCB has the ICs already attached to it. I wasn't able to find out what ICs they used, but there's a bunch of ICs that'll give you a square wave. I think it's a square or a saw is what you have the choice between. Shape is sine or square wave, so you have an option to choose there. But this is all the pieces involved. The PCB has the SMD components already soldered onto it, and then you do through-hole componentry. And I already loved this idea, and I knew I was going to feature it in the show, but what absolutely sealed the deal for me is that if you open the assembly instructions, it is this beautifully made PDF that takes you through every part of it and explains what you're doing. It gives you the block diagram, but a very easy to understand block diagram, and then tells you all the tools you will need, like a screwdriver and a damp sponge for your soldering iron. Explains what's in the box and explains how to put it all together piece by piece. A really, really easy to follow guide, and the kind of guide that would be the perfect thing to again work through with a child. So once again, no affiliation whatsoever. I just thought this is something that was worth a shout out because it's such a wonderful idea for a product. If you're looking for a gift idea that combines the things that we love, it's an IC with some simple componentry that you put together yourself to make a wibbly wobbly synthesizer. I just love the idea. This is Ivan Miranda's marble clock. Now, if you're familiar with the name Ivan Miranda, it's because we talked about him on the show, but not for quite a while actually. But he is the creator of huge 3D prints and various functional and otherwise 3D prints. His YouTube channel is just wonderful if you're into ridiculously massive 3D. Well, yeah, there's a tank. The 3D printed tank is the first thing you see on his channel. It gives you a rough idea about what we're talking about here. But he has built a lot of incredible things, as you're seeing, from go-karts through to giant 3D printed diggers that actually work. This is a 3D printer that is built. He's used 3D printers to build even bigger 3D printers, and that's kind of his thing. But the marble machine, the marble clock that he's making right now, is a step above. It's a thing of beauty. I'm not going to spoil it. I don't want to spoil the moment that it all comes together, but this is part 2 of the series where he talks about this huge all 3D printed machine, which as you can see has various different, if I go back to the start of it here, maybe we'll see it a little better. Yeah. Various chutes for the marbles to go down, and the idea is they can be stopped just here, they pull down at the bottom, and they get carried up this ladder right here. And this video goes through some of the wonderful embedded technical details that we are so interested in. Because if to set the time up and to actually have the time show here, again, the idea is if I go back to here and I show you the thumbnail. Look, you're seeing the thumbnail just here of the clock, and so there's 23:01. The idea is the white marbles will be in the right position. Actually getting that to work is technically not easy because they all go up this chute in the background, and you need to, get the right marbles in and the right marbles out. And you're seeing one of the answers here. This is a solenoid that fires, and it fires at all the marbles and just pings them all out. And these are like cheap hobby solenoids. But once you've got your hobby solenoids shooting the balls out, well, how do you know which ones to shoot out? Well, he tries various different ways to actually detect what color the ball is and settles on infrared. And I'm not going to spoil all of it. There's just wonderful little bits of engineering that need lots of work. All these tiny little decisions that require huge amounts of printing and huge amounts of actual background work to just test out on a machine this big. It's a real feat of engineering and the true kind of spirit of makerness, if there is such a thing. I absolutely suggest heading and watching his videos. Even if you're not really into the 3D printing side of things, this is something just a little bit different. Now, BeagleBoard just released a new, board, and it's called the BeagleV-Fire. And let's just jump straight into this. I'm not going to spend too much time on it because it's so above my head, but it is definitely a very exciting thing because this is a RISC V and FPGA single board computer that runs Linux. That's already a number of words together that's going to be very exciting for a few people. And so I'm going to jump straight into the stats of it because I don't know anything about this. This is something that's completely above my head, which is a really interesting thing to happen. And it's happened to me a couple of times recently. I've had to talk about AI recently as well. But yes, it is a single board computer. And as you can see, it has, a bunch of inputs and outputs and is based around the microchip PolarFire chip. And it is a RISC V CPU with 4 64-bit application cores and 1 monitor boot core, but it also has an FPGA on it as well. It also comes with 2 GB of RAM and a 16 GB eMMC and Ethernet and M2E key support, if I remember correctly. Yes, a little M2E, so you can add Wi-Fi via an M2 slot. And it has a USB Type-C connection and a serial wire debug. Now, oh, and a micro SD slot as well. That's also very important. There is one thing about it that is very interesting straight out of the gate. It comes with Linux on it, and that's going to be kind of fun. But this is definitely something for developers. If you want to get into RISC V, if you want to learn about FPGAs, this is the board for you. You're not going to be using this in a general day-to-day sense in the same way that you would a Raspberry Pi. But the price is incredible. It's $150. Now, I'd have to do a bit more digging to really understand how they've done that because the microchip board, the microchip chip on it, the system on chip, Microchip have their own evaluation board for it, and it's about $600, maybe more. So I don't know how they've managed to make it so cheap. I don't know whether this version is slightly pared down and not necessarily using all of the features of the chip or the FPGA or exposing all of the features. But either way, for $150 to get a board like this, it's kind of incredible. BeagleBoard, have been there since kind of day one. In the early days of Arduino and Raspberry Pi, BeagleBoard were the third option. And I always loved the idea that you just connect to a board and you use your browser as the IDE. That was a very nice idea and one that's stuck with me because I still use their browser IDE when I'm programming the Baylor, which is based on the Pocket Beagle. It's that wonderful synthesizer library and team and just wonderful, amazing altogether thing. Anyway, I'm getting off topic. If you would like to know more about the BeagleV-Fire, do look at the link in the description. I'll be linking to the BeagleBoard website, and there's a bunch of information on here already. And of course, a few other people have talked about it who are a little more qualified too than me. I'm sure there's a CNX software article that goes through all of the gory details in the way that I will be doing, that I am not capable of doing. But it's something that you had to talk about because, yeah, $150 SBC that's RISC V and an FPGA all in one, it's just such an incredible thing. Of course, this is not the only thing that BeagleBoard have put out recently. In fact, we spoke to Jason Kridner, who's the head of BeagleBoard, at Embedded World a couple of years ago. Or was it Electronica? I lose track of conferences. And this was just around the time that the Beagle Play and the Beagle Connect Freedom were released. And this is another completely original idea for an SBC based on a Texas Instruments part. And this one has click connections and Beagle Connect Freedom. The Beagle Connect Freedom also is a clickboard connected long-range Wi-Fi device, and these things play together very nicely. We don't have the new board in stock quite yet because it's literally just been announced, but we'll also have it in our shop at some point. So if you do want to support the Electromaker Show, as I say at various parts in this show, this is absolutely the best way to do so. This is what pays for our show. But yes, I'll be talking about this more when I have one, because this is a no-brainer for me. If I ever want to mess around with a RISC V and FPGA, it's going to be on this board. We're going to close out this week's show by talking about this, the Blues Starter Kit. Now, Blues are an IoT company that specialize in cellular, Wi-Fi, and LoRaWAN communication, and they just released this. In the middle, you're seeing an M2 keyed thing, a module called the Note Card, and this one combines cellular and Wi-Fi connectivity, which is why they have the new kits. But the board down here, this is an STM32-based development board called the Swan, and the big board you're seeing is the Note Carrier, which, well, it carries both of them and breaks out a bunch of the pins and adds just a few nice things. Now, we'll get onto that in just a moment. I'm going to try and keep this incredibly brief because I have actually just released a quite long review of this on the Electromaker website in written form. If I tried to go through everything I wrote, we'd be here until tomorrow. So I can't stress enough how much I'm going to have to really whip through this at a pace. The review goes through everything quite slowly, including how to get started with it, how easy that process is, and then goes through to some of the more potentially more interesting use cases for it later in the review. Again, link in the description. But if I had to be very brief about it, Blues is two things, actually. It's a hardware company that gives you the amazing Note Card, and this thing can act completely independently of a host MCU, by the way. I mean, I have the Swan plugged in right here, but I'm going to unplug it right now because we don't need, whoops, I almost dropped it. We don't need this MCU right now. It's a perfectly fine STM32 based development board, but we're just not going to use it right now. So we're plugged into the baseboard, and that is attached to the Note Card, and there's the aerial coming off it, and this thing does Wi-Fi and cellular. So that's one arm of it. The other arm is the cloud platform, and this is the Note Hub, and this is where you log all of the events. So for example, this is an event where I sent humidity and temperature data to the cloud. Admittedly, it's fake humidity and temperature data generated on the microcontroller, but you know, you can attach anything you want to this. There are a few different places you can actually plug things into. For example, the Note Carrier F here has a couple of quick connectors here for adding Sparkfun and Adafruit stemmer QT things, and all of the pins there as well. But this, this is where you send all of your data to. It's also where you talk about all the different devices in your fleet. I only have one, of course, and it's where you can route stuff as well. So you can send stuff to any HTTPS server, any MQTT server, Amazon Web Services, send messages, SMS messages via Twilio. You can even populate stuff in Slack channels if you want to. And we're going to come back to the cloud service in just a second because there's some really amazing things in this. But okay, back to the hardware. What makes it such an easy thing to get started with? So one of the things that makes Blues special is how easy it is to get started with it. I've moved myself down to this part of the screen because this is the Blues website. You go to the Blues website, you click the Getting Started guide, and this is the quick start for the Note Card and Note Carrier F, which is all I have here. Once again, I do not have the MCU development board attached to this right now. This is just the module attached to my computer via USB. And as you'll see, there's a terminal here in the browser. If I follow this tutorial, it gives you a little bit of back and forth as to exactly how it works. The MCU sends things to the cellular or Wi-Fi Note Card, although as we're about to find out, you don't actually need an MCU. But it creates JSON commands to send to the Note Card, and it is communicated to the cloud securely. And then that can be passed on, as I said a moment ago, to any other route. But that also works in two directions. You can go from the cloud to the Blues Note Hub, and then to the Wi-Fi Note Card, and then to the MCU. And one feature that I think is really quite interesting is that this Note Carrier is connected electrically to the boot and reset pins of the MCU. So you can do an actual update, which is an over-the-air update, but it's not OTA in the sense that we normally know it. This will actually send firmware from the Note Card to the host MCU itself, and you have no chance of bricking it whatsoever. Because if you do send code that stops it working, you just send new code. It's just like uploading Arduino code that doesn't work to an Arduino. You can just upload new code because you can always put it back into bootloader mode, and that's what this thing will do. Now, if you want to talk to a Note Card with your computer, you need to connect to it via USB. So I'm clicking to click USB here. You won't be able to see that because I'm in windowed mode, so let me just take a little photo of it. This is a window that's saying, do you want to connect to the Note Card on COM7? Yes, I do. And here we are. We're now connected to the Note Card. And this is how you do every single thing with the Note Card. You send JSON requests. So I'm going to send a request for the card version, and it spat out the card version. This is the Note Card 531, and it has Wi-Fi, it has cell, it has GPS, and if I want to connect it to my Note Hub, then I just set up a new project, like it says here. You create the project, you're given a link here, and then you just use this JSON command. And I'm going to make this a little bit bigger so it's a bit easier to see. So request, set your hub, your product number, and then when you get these double brackets back, you've set it. So that's how you connect your hardware to the cloud. It's already done. And we don't have anything to send to it right now, but if you want to start a sync, you say request hub sync. I'm going to click try it, and I'm going to click go. And now this little terminal down here gives me, again, the double brackets. That's just a JSON OK sign. It's saying, OK, we have received your request. And now I'm going to ask for the sync status. So the sync status is, okay, the modem is now on, the sync is true, but it has been requested. We haven't actually had any kind of a sync yet. And of course, right here, it's actually saying this in the terminal as well. But if you were doing this from the command line, which you absolutely can do, you can just set sync status, and every time you ask it, it'll give you a sync status back, or you can tell it to be verbose and give you updates whenever it has them. And as you may notice, the eagle-eyed among you, the times have changed, literally, here on the events page of NoteHub since I last showed you it, and the fake humidity and temperature data that I have been sending through from the NoteHub is now arriving here. So this way of talking to the note card constitutes the entire way the note card works and the entire way the Blues system works. It's incredibly elegant and simple in that regard. And again, that's one of the reasons why this review was so glowing. I want to remind you, this is not a paid review. Blues did send me this thing, but I got it out the packaging and wanted to give it a cursory check through. Everything works the way that they said it did before kind of writing up a review about it. I spent a lot of time playing with this thing because it's a joy to play with. Because once you get this idea in your head that everything is a JSON request, everything it does is a JSON request, things get really interesting. So this that we just did using the, we used the web terminal, but you could use a note card CLI. It has a perfectly good command line interface as well. In fact, the command line interface is kind of interesting because you can just send commands directly via the interface, or you can make a file of commands that it will execute in order, or you can use the note card play feature, which is an interactive CLI that you send request and you get the in real time, you get kind of feedback. That's something to talk about another time. But yes, you can send this via the web API, or you can use a microcontroller board. So the Swan microcontroller board that I've just plugged back in here, like I said, STM32 based development board. If you are familiar with Platform IO and Visual Studio Code, you'll be very happy here because it's a Platform IO thing. I mean, they have an Arduino IDE plugin as well, or library as well. They have a MicroPython library and a Python library, and all of these libraries do more or less the same thing. They just give you an easy way to create the JSON commands that you send to the note card. And this is the quick start. You set up Platform IO and then you create your code. It uses I think this one still uses the Arduino.h code, so you'll be very familiar with it if you programmed Arduinos in Platform IO. And you're defining things like your serial port, you're defining things like your project name here, that might be familiar from before, and here we go. This is creating a JSON request to set the hub with the product and the product ID like we just did before. I'm low on time, so I just wanted to say very quickly a couple of things that I thought were interesting. Setting environment variables from the cloud is a very fun thing to do. Here in the cloud, here is my device. This is the Blues Power project, and there's a device attached to it just here. If I go to the environment variables, I can send things to this specific device. So let's say I wanted to create a new key, which was sensor interval, and I wanted this to trigger every 30 minutes. I wanted this value to be the sensor interval. So on my microcontroller, I had a variable called sensor interval, and I wanted to change its value to 30 minutes at runtime. I would do this, and then this is the code that I would use. We create another JSON request, and the request is to get the environment variable. And this is, it's reading interval, not sensor interval, but same. It's if there is, requests is reading interval different. If so, it will trigger a callback, and this callback here just changes the interval seconds at runtime on the microcontroller board. So you have a modicum of control as to what's happening on your microcontroller board from the cloud. This isn't a full-on over-the-air update, but it's more control that you would usually expect. But it does go much deeper than that. The environment variables are one thing, but just before I finish, there's a couple of things I want to mention. Actually, just before those couple of things, Blues' YouTube channel is absolutely fantastic. There's a couple of videos in the body of the review. If you click on the titles of them, it'll take you to the actual videos. This is the IoT project that I just massively skipped over in the Getting Started guide. This is a step-by-step guide through it. And all of the videos on their channel are fantastic. There's project ideas, there's talks, and as you're about to find out, there's a step-through guide of one of their coolest features. Again, just before I move on from this as well, by the way, I just wanted to mention, if you're interested in messing around with this Getting Started guide, there is a simulator here which simulates connecting to a note card. Just wanted to mention that. Okay, so as a getting started guide for someone who is not an engineer and a beginner, Blues is incredibly easy to get started with. That's the reason that I love this thing so much. That's why I spent so much time playing with it over the last little while. But in terms of slightly more like deep engineer level stuff, the attention pin is something that requires, well, attention. The note card has an attention pin that can once again be triggered in the cloud, a bit like an environment variable, but this is a physical electrical variable, I suppose. That attention pin could be connected to the wake pin of a sleeping microcontroller, for example. Meaning that you have timed control over when a microcontroller should wake up to do different tasks. Anyone who's messed around with sleep and wake cycles and the ways that you can trigger them will know that that's an incredibly powerful thing to have. This isn't an over-the-air update, it's just an over-the-air signal. But while we're talking about over-the-air updates, the outboard DFU is incredible. This video is absolutely worth watching. It will go through it step by step. But let's say that you have firmware that you have developed for your microcontroller and you want to replace the firmware on your microcontroller in the field. You could do an over-the-air update, yes, but that requires a lot of memory, and over-the-air updates have the potential to brick your device if they go wrong. The note card is electrically tied to both the boot and reset pins on the Swan microcontroller. This microcontroller, if you want to put it into bootloader mode to put code on it, you hold down boot, you hold down reset, you let go of reset, you let go of boot. The note card will do that for you remotely, and they have a bin packer that you use the note card CLI to put together, and you can pack your code down into a manageable format that you can then upload into the Note Hub. So if you go to firmware here, I don't have any firmware on this computer. I did all of my fiddling on the laptop, unfortunately, but you can upload firmware here, choose a file, you create the bin pack in the note card CLI. It's very easy to follow. Again, I recommend watching this video, and then you can upload that to the microcontroller, and it does an actual upload of code in the field. It puts it into bootloader mode, uploads new code to it. If you create code that would have bricked a microcontroller, usually it's not bricked because you just put it back into bootloader mode and then put the code back in there. It slots right in. It doesn't overwrite the bootloader. It's exactly the same as using Arduino or doing it by hand. It's a really awesome idea. I have tried my best to keep this brief. I have probably talked for longer than if I had just read the entire article that I wrote about it. But in short, yes, very glowing review. Big fan of this. Really looking forward to the Blues LoRaWAN kit that they're going to be coming out with. Or they have a LoRa note card coming out soon, I think. I want to stress again, I've been very gushing about this. Blues did not pay me for this review. They did send me this kit for free, but they had absolutely no say over what I did with it and what the review was like. They didn't get to see it before I published it. It's just one of the coolest things I've played with in a while, and I am really glad that I had the time to do so. But anyway, that is it for the Blues review. You can find a link to it in the description of this video, and I am really interested to see what you all think of it, because as a non-engineer, I am blown away by simplicity, and the idea of this entire thing using JSON commands and not necessarily even needing a host MCU is the simplest thing I've come across in ages. If you are someone who does work with these kind of devices and have had to do it the hard way before, does this thing appeal to you? That was our show for this week. Thank you so much for joining me. Thank you for your continued support. And as always, I'd love to hear what you thought of this show and the things in it. It's so nice to talk about Miranda again and to talk about kind of large-scale 3D printing maker projects. I always love talking about those ones, but they're the first things that get cut for time, usually because there's always so much fun hardware and embedded stuff to talk about. But yes, also Embeetle, what do people think of it? Will people be using it to program these amazing little RISC V, the 10-cent part that everyone went crazy about a little while ago? It certainly seems to me the lowest barrier of entry to get these things programmed, which is, an amazing thing given how cheap that they are. Anyway, I could waffle for a very long time, but it is the end of the show. I will chat to you next week. I hope we have a safe, fun and creative one, and I'll see you then.